All right, guys, we are back. This is going to be, again, we're in topic 4, rate of change, and we are on student activity sheet 2, exploring constant rates. We are going to split this into 2 sections. So I'm going to go ahead and do the first section with you guys. As we start looking at graphs and whatnot, I want you guys to think about elevators. This is a really cool elevator that we can see go up and down inside the building. Sometimes they're against the wall and we can't actually see their movement. I know down in Orlando, there's a really awesome hotel. It's the Marriott down there that the elevators actually go up through the ceiling and then they become from inside the lobby, then they become on the outside of the building, and it's a really cool view. Okay. But I want us to think about what an elevator would look like. In terms of its vertical, it's up and down, meaning close to the ground, all the way up to the ceiling in terms of time moving. Okay. So that's what we're going to kind of look through in this section here. Okay. As elevators go up and down, graphs can show us their height, whether it's above ground or below ground, in proportion to time. So we're going to I'm going to play around with this a little bit. So we're going to look at elevator A here. And if I say that maybe it wants to start below ground. So I'm going to drag elevator A below ground to like the subfloor 3. So it's like the third floor of the basement. And I'm going to take elevator B all the way up to the top floor of this hotel, which is floor 12. And elevator A, I'm going to have move at a rate of 2 seconds. And elevator B, I'm going to have move at a rate of -2 seconds. And let's just see what happens here. So over time, you can see over time, this elevator is going up as time moves on. And with elevator B, it's moving down the graph as time moves on. And then this here on both of them, it shows from about 7.5 seconds through 10 seconds, the elevator is standing still because it has this red one. Elevator A has no more room up here to go. And elevator B is down here in the basement. It's bottomed out. That's why it's now showing stopped. Uh-oh. What happened to my agile minds? There we go. Okay, so with this, we have 2 elevators again. We're going to go through different situations involving both of these elevators, and we're going to sketch the graph for each pair described, and then we're going to check the animation to see if our graphs were correct. So on this first one, they want elevator A to start at floor 3. So I'll help you out here on this first one. Elevator A, whoops, it doesn't want me to do this apparently. Okay, so elevator A is going to start at floor 3. And it tells me that it's going to go at a rate of -2 seconds. Elevator, meaning it's going to go down. And then elevator B, they want to start also at floor 3. But it's going to have a speed of 2 seconds. So let's see what happens here. Over time, we can see elevator A is going down, elevator B is going up. But what you're going to see is elevator A stops a lot faster. They have no place to go before elevator B. So if I look at my graph, I can show the same thing here. Okay. Now, what I want us to do is we're going to do elevator A first at floor 11 at a rate of -2 seconds. And elevator B is at floor -3. So it's in the basement at a rate of +2 seconds. So over here, what I did was I showed you elevator A is my pink pen. They said they want elevator A to start at floor 11. So I took elevator A up and I put it at floor 11. And elevator B, they wanted at -3. So I took it all the way down to the basement. And what I did was I started going up. It said that elevator A dropped at a rate of 2 floors per second. So by 1 second, I had it down to the 9th floor. At elevator B, because it was going up 2 floors, So I went up 2 floors and over to 1 floor. Okay, and I continued this until I got my whole graph showing where it hit the top floor and had time left, and here hit the bottom floor and had time left. So let's see if that's what happens here. So we're gonna go elevator A is gonna start up at floor 11, and elevator B is gonna start all the way at the bottom at -3. Elevator A moves at a rate of -2 seconds, and elevator B moves at a floor of +2. And let's see if our graph looked like that. Great, it did. Perfect. I'm so smart. Okay, so now we're gonna do the same thing here on part C. Elevator A is going to start at floor 12 and goes down. That's the negative. It's going down at a rate of 1. Elevator B is going to start at the same floor and go down at a rate of 2. So what I did on my graph here, you can see I have them both starting up here, both my pink line for A and my blue line for B. And I said that elevator A went down at a rate of 1 floor per second. So it went down 1, over 1. And then they went down 1, over 1, and you can see that I continue that. Elevator B in blue went down at a rate of 2 seconds per floor. Again, I know it's going down because of the negative, so I went down 1, 2, and over 1. Down 1, 2, and over 1. So let's see if my picture matches what they have here. So elevator A is at floor 12. Elevator B is also at floor 12. A is going down 1. B is going down 2. So we can see how they start to separate in floor. Elevator A goes down 1, over 1, down 1 floor each second. Elevator B is going down 2 floors each second. Okay, and we see that elevator B reaches that bottom floor long before elevator A even reaches the second floor. So that time really adds up there. Okay. And now elevator D, I'm just going to go ahead and plug this one into the computer here. For part D, elevator A is going to start at floor 12 and go at a rate of down 1 floor per second. Elevator B is going to start at floor 8 and go down 1 floor per second also. In my graph, I show the 2 different starting points, and I show that it goes down 1 floor, over 1 floor, down 1 floor for each second, down 1 floor for each second. Elevator B, the same thing, down 1 floor for each second. So here's my graph, and I show that elevator B ends up in the basement level 2, and elevator A ends up at floor 2. So let's see what happens here. Try again. So we can see they both ended at the same time. Elevator A was on floor 2 and elevator B was in the basement floor 2. Let's go on to the next problem. Okay, so the last time we were given a starting floor and a rate, and we needed to find and we needed to graph it. This time, I'm going to give you a graph, and I want you to think about where these would be. So let's look at elevator A first. It's showing me that they want it, look up to the top. That's going to be our starting point. So I'm going to take elevator A up to the first floor, and elevator B looks like it starts on floor 10. So let's look at how it goes down. Elevator A in 1 second's time drops 1 floor. So that means it's going to go down by 1. Elevator B, down 1 floor, in 1 second. So same thing here, and let's see if it matches. And it looks like it does. Okay. So for my next elevator, my next one, let's see what they give us. So now this time, let's see, elevator A, they want up here at 10. So we're going to call that floor 10. Elevator B is starting down here in the basement. So let's look at the rate at which the elevator A goes. It looks like it's going down 1 over 1. So that's going to be down 1 second. Elevator B looks like it's going up 1 over 1. So that's going to be positive 1 second. And see if that's what happens. And it looks like we're good. So let's go ahead and record our responses here. Again, A is starting at 10. B is starting at -2. I know my scribble there, guys. A is going down 1 floor per second, and B is going up 1 floor per second. Let's go to question 3. This time, it looks like A is starting way up at the top at the 12th floor. B is starting, it's at 0, so that means it's starting at the ground floor. So let's look at their rate. A is going down 1, well, we're not at 1 second yet, so down 2 over to 1 second. So they're going at a rate of down 2 floors per second. So it's going to be -2. B is going up 1 floor per second. So we're going to call that 1. Let's see if it matches. Oh man, I am so good at this game. Okay. And so we're going to go ahead and call that. A is starting at 12 with -2 with a rate of -2. B is starting at 0 with a rate of 1. So this time it looks like both of them start at floor 3. So I'm going to take both of them up to floor 3. And I'm going to look at my time here. A is red. So A is going to go down 1 over 1. So that's down 1, -1. B is going up 1 floor. So it's going to go up 1 over 1. So it's going to have a positive 1. And we are good. So go ahead and record that on your paper, guys. Again, both elevators started at at 3. Elevator A went down 1 floor per second. Elevator B went up 1 floor per second. Okay, let's turn our page. Let's do problem 5 with it. Okay, so let's see. Let's go. Elevator A is up at 10 floors. Elevator B right here. Okay, so let's start with A. It looks like they are going down, so it's going to be negative. So -1 in 1 second. -1 in 1 second. Elevator B, they're not moving up or down for any time. So we're going to call that a 0. There is 0 speed to the elevator. And let's see if that holds true. Excellent, excellent. Looks like it does. So let's go ahead and record that. Go ahead and record that on your paper. Starting at floor 10, starting at floor 4. A goes at a rate of -1 and B has a rate of 0. So let's do the last one in this section. And we've got both A and B starting way down in the basement. I didn't know that basements consisted of 3 floors, but apparently there are 3 floors to a basement. So let's look at elevator A. Holy cow. In 1 second's time, so remember guys, we're only looking over one space here. In 1 second's time, elevator A goes up 1, 2, 3, 4 floors. 4 floors in 1 second's time. So I'm going to go ahead and record that. Whereas elevator B in blue is going to go up 1 floor in 1 second, up 1 floor in 1 second. And this was a tricky one, so let's see if I got that one. Holy cow. Could you imagine being on elevator A right now? They're flying. But their ride certainly wasn't long because now they're stuck up there while B is still moving. All right, looks like I had that right, so we'll go ahead and record that information. Both started at in the basement floor 3, so -3 floors. A moved at a rate of 4 floors per second, and B moved at a rate of 1 floor per second. So here now, guys, I want you to think about the last couple problems that we did. How did we decide which graphs? How did we decide our plans? How did I decide what my speed was or their starting point? Okay, so first question: how did we decide what the starting floor was? Well, remember, we went and looked at the graph to see where the lines were at. And that told me that up here, elevator B had to start at the 4th floor. And I went all the way up at 0 seconds for elevator A to start at floor 10. So let's see what they say. It said the starting floor is indicated by the point where the graph touches the y-axis at 0. So basically, guys, what that means is at 0 seconds, where was the elevator? Well, at 0 seconds, A was at 10 and B was at the 4th floor, by the point where the graph touched the y-axis. The second question, guys, was how did we decide what the rate was? Okay, well, remember, I sat and I counted. I knew in 1 second, here's my 1 second, one space on the graph, it went up 1 floor before it was 1 second over. Okay, so we looked at the rise of the graph. So with that, they say we determined the rate by looking at how far the elevator traveled in 1 second compared to the number of floors in that second. Okay, so again, we looked at how far the elevators traveled in 1 second's worth of time. Okay, so now what I want us to do, I want us to think about all the work that we had just done with our elevators. We're on the next page, question 4. Okay, of all the work that we just did with the elevators, what were the rates when the elevator graphs looked the steepest, and what were the rates when the elevator graphs looked the least steep? Meaning, were they going up really fast or going down really slow? Okay, and what that is, okay, the graphs were the steepest, and I want you guys to think about this. When I'm talking about steepest, okay, when I'm talking about steepest, I mean either going up really fast, so this is steep, going up really fast, or down really fast. Okay. When it looked the least is when we're going up nice and slow or down nice and slow. It's not going really fast. Okay. So with that, the larger numbers, when we had larger numbers like -3, +3, -4, +4, that's when our elevators were shooting up or down like it was a roller coaster. But when they were steep, meaning they went nice and slow, they were closer to 0, or they were like a +1 or a -1 speed. Let's go to the next page. Okay. So when we were in the elevator, we saw the 2 different elevators could be moving at different rates. With this, mathematicians, guys, we look closely at ways of connecting the different speeds to determine different rates with things. Speed. Hold on. Okay, we're down here. Okay, the speed describes a change in distance relative to a change in time. So with speed, we are comparing the change in distance to a change in time, whereas a rate describes the change in one measure to another measure. So let's look at some of this stuff. Again, speed describes a change in distance relative to a change in time. A speed can never be negative. Think about it, guys. Even if we're walking backwards, we're still moving. We're still going a speed. Okay? We're still moving. Therefore, we have a positive speed. Some examples of rates. Okay, again, a rate is a change in one measure compared to another. Okay, so some examples: miles per gallon, beats per minute. That's like a heartbeat. We talked about this in student activity sheet 1, or the temperature change over the course of an hour. Okay. The next question: is it possible to have two elevators moving at different rates but the same speed? Okay. Did we see this? Did we see they were moving at different rates but at the same speed? I want you guys to think about that for a second. Okay. When two elevators are moving in opposite directions, they would have different rates. That's where we saw the positive floors, the negative floors. But they could have had the same speed. Look at this graph here. They're going down 2 floors per second. This one's going up 2 floors per second. Their speed is still 2 floors in a second. So yes, if they were moving in opposite directions, if one is going down and one is going up at the same speed, they have different rates. So that would be our +2 versus our -2. So that's going to be the end of our part 1. I want you guys to take a look at reinforced question number 7, number 8, number 9. It seems like a lot, guys, but the graphs take up space. And that's it. Questions 7, 8, and 9. And your teachers will help you go over them.